So we left off, one of the last homework assignments we had was a worksheet that looked something like this. Dealing with formulas. So here we've got to find the slope of the line that contains these 2 points. So for this first one, remember, we labeled them points 1 and points 2. And our slope was y1 minus y2. So what's going to go on top here? Well, actually, it'd be 12 minus negative 2. Good. Y2 minus y1. And on bottom, it's x2 minus x1. So what goes down here? Negative 4 minus 3. Perfect. So what is 12 minus a negative 2? 14. Good. And negative 4 minus 3? Careful. Negative 7. So that divides out to be a negative 2 for our slope. Perfect. I'm going to jump down here to this one, number 4. So what's going to go on top? I'm going to move that over. What's going to go on top for that one first? 23 minus negative 7. Remember, it's y2 minus y1. Yep. And on bottom? Three minus negative 2. Good. So what is 23 minus negative 7? Remember, minus a negative is plus a positive. 30. Perfect. 3 minus a negative 2? Minus 3 plus a positive 2 is 5. So 30 divided by 5 is a 6 slope. So we had a slope of negative 2 and a slope of 6. Midpoints. If you remember midpoint, we average together the x-coordinates and we average together the y-coordinates. So let's look at number 5 here. To find the x-coordinate, what 2 numbers are we going to average together? Perfect. 3 and negative 5. So it'll be 3 plus a negative 5 divided by 2. What is 3 plus negative 5? Negative 2, and negative 2 divided by 2? Negative 1. Good. And now over here for the y's, that's the y for the y coordinate. What 2 are we going to average together? Negative 8 and 2. So negative 8 plus 2 divided by 2. What is negative 8 plus 2? Negative 6, and negative 6 divided by 2? Negative 3. So the midpoint, the point that's exactly between those 2 points, is negative 1, negative 3. So over here, let's do number 8. The 3, 7, and 93, negative 49. What points am I going to average together to find the x-coordinate? Perfect. 3 plus 93 divided by 2. 3 plus 93 is 96. 96, that should be divided by 2, is 48. Good. And for the y-coordinate, we're going to average together 7 plus negative 49 divided by 2. That doesn't look very legible. Let me try that again. What is 7 plus negative 49? Perfect. Negative 42, and then divided by 2 is negative 21. So the midpoint, the point that's exactly between those 2 points, is 48 and negative 21. Good. Now these, I gave you the midpoint and one of the endpoints, and I wanted to find the other endpoint. So to do that, we had to do a little bit of algebra. So I'm going to slide that over. Come on. So we can work side by side here. So for the first one, we're given that the midpoint is the 3, 2, and the first endpoint is negative 1, 7. So we're trying to find the other endpoint, which is B, given our midpoint is 3, 2. So if you remember, we let this be X and Y were the coordinates for point B. And we knew that in our midpoint, we average the X coordinate, so negative 1 plus X over 2 has to give us the X coordinate of the midpoint. That's the 3. What did we do with that? To solve for X, we have to multiply by 2. So negative 1 plus X equals 6. And then add 1. So X equals 7. So the X coordinate here is 7. For the Y coordinate, we know that 7 plus Y divided by 2 gives us the Y coordinate of the midpoint of 2. So what do we do there? Multiply by 2. So 7 plus Y equals 4. And then subtract 7. So Y equals negative 3. So the other endpoint is 7, negative 3. Okay, then the next thing we did was we talked about the distance between points. And that's what we're looking at down here. I want to know the distance between 3, 9 and negative 2, negative 3. And if you recall that formula, the distance is basically off that Pythagorean theorem, a squared plus b squared equals c squared. It was the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I call this point 1 and point 2, what's going to go into my formula here? What's going to go in here for x2? Negative 2, good. Minus 3 is x1. Perfect. What goes in for y2? Negative 3, and then minus 9 is y1. Very good. So then next, what is negative 2 minus 3? Perfect, negative 5. And then what is negative 3 minus 9? Negative 12. Then we have to square those. What is negative 5 squared?
Negative 25.
Careful. When you do that on your calculator, if you do negative 5 and hit x squared, it's going to try to tell you negative 25. But remember, you've got to put it in parentheses, negative 5 in parentheses, and then squared. So it's a positive 25. How about negative 12 squared?
That would be positive 144.
144, perfect. And now we have to add those. 25 plus 144?
169.
Is 169. And finally we square root. Square root of 169 is
1
13, perfect. So the distance between those 2 points is 13 units. Okay, then the last thing that was on that worksheet that I wanted to make sure we remember how to do, because we're going to need it again today. If I have an equation like y equals 2x plus 4, where do I start graphing that? The positive 4, very good. Now from there, the slope is the 2. I make it a 2 over 1, so from that point I go
Up 2 over 1.
I rise 2 and run 1. My line goes through those points. Now you notice I drew it very carefully there. We can actually go up 2 over 1 and then keep going up 2 over 1. And I can go back the other way if I want to. Over 1, down 2, over 1, down 2. So that if I want to make sure I get those points exactly where they need to be, I can do that. And for what we're going to do in the second half of class today, we need to be precise about those. So over here, y equals 6 minus 3x. Where do we start?
6.
Positive 6. That's right here. From there, what do we do?
Go down 3 over 1.
Perfect. We make that negative 3 as a negative 3 over 1. And we go down 3 over 1. And there's my second point. Again, I could keep going down 3 over 1. Gives me another point. Down 3 over 1. Down 3 over 1. My line goes through those points. Finally, this last one, y equals 1/2 x minus 3. Where do I start?
Negative 3.
Negative 3. Good. And from there I go
Up 1.5 over 1.
you can go up 1/2 and over 1. You keep going up 1/2 over 1. Or you can go up 1 over 2. Works the same. Up 1 over 2. You're going to have the same spot. Okay, so we'll come back to that later on. Then we talked about parallels and perpendiculars. So this is the worksheet you got on the Friday that we last met. This first piece here, I just want to identify what the slope of a parallel line would be. So to figure out what the slope of a line parallel to this one would be, I have to figure out the slope of this line. So for number 7 here, y equals 3x minus 7. What would the slope of that line be? 3. Very good. Whatever number multiplies x is the slope. Well, parallel lines have the same slope. So the slope of a line parallel is just going to be 3. For number 8, what's the slope of that line? Careful. Negative 1/2. So that line has a slope of negative 1/2. The slope of a line parallel to it will have a slope of negative 1/2. Number 9, what's the slope of that line? Negative 2, and a line parallel to it will have a slope of negative 2. For number 10, the slope of this line is 3/4. So a parallel line would also have a slope of 3/4. Number 11, the slope of this line is 7/9. So a parallel line would also be 7/9. Number 12, the slope of this line is 5. A parallel line will have a slope of 5. 13, the slope of this line is negative 6 over 5. Good. And the parallel will also be negative 6/5. For 14, the slope of this line is
-4.
-4, and a parallel line will also be -4. 15, the slope of this line is
2/3.
2/3, and a parallel line will also be 2/3. Well, our next step here is we're going to talk about perpendicular. Remember, perpendicular, we exchanged the rise and the run, so it was a reciprocal. But a positive line, to be perpendicular to it, we must have a slope with a negative slope. So it was the opposite reciprocal. So what does that mean? Well, number 16 here, the slope of that line is 3, right? If I put that over 1, the reciprocal of 3 would be 1/3, and since it's positive, the opposite would be negative. So the slope of the perpendicular would be -1/3. For 17, what's the slope of the line given there?
+2/1.
Okay, good. The line given would be a slope of -1/2, so the perpendicular would be +2, or +2/1. 18, the slope of this line is -2, so the perpendicular is going to be, careful, +1/2. There you go. Those whole numbers are hard. You got to remember that it's -2/1, so it's 1/2. Number 19, the slope of this one is 3/4, so the perpendicular would be -4/3. Very good. 20, the slope of this one is 7/9, so the perpendicular would be -9/7. Very good. 21, this is a slope of 5, so the perpendicular would be -1/5. Good. 22, the slope of this one is a -6/5, so the perpendicular would be perfect, +5/6. 23, that has a slope of -4, so the perpendicular would be +1/4. Perfect. And 24, the slope is 2/3, so the perpendicular would be -3/2. Perfect. For these next ones, we're going to go back to doing them side by side again here. For number 25, we want to find the equation of the line that is parallel to this line, to the given line, and has a y-intercept of 3. So that equation is y equals 3/4 x plus 12. The only information we want out of that is the slope. What is the slope of that line? 3/4. So a line that is parallel to it will also have a slope of 3/4. So we start out this equation as y equals 3/4 x plus whatever that y-intercept is. Now, to figure out the y-intercept here, we're actually just given that the y-intercept is 3. So y equals 3/4 x plus 3 is what that comes out to be. For 26, again, y equals 7/9 x plus 1. The only information we want out of that equation is its slope, which is 7/9. The parallel will have the same slope, so it'll be 7/9. So y equals 7/9 x plus b. What's going to go in for b? -1 is the y-intercept. So y equals 7/9 x minus 1. 27 is very similar to that. It's going to give you y equals 5x plus 5. 28 gets a little more interesting. We still want the equation of a line parallel, but it's going to go through 5, negative 4. So we've got y equals negative 6/5 x minus 3. What do we want out of that equation? The slope is negative 6/5. Very good. That's all we care for. So what's that tell us about starting our next equation? Perfect. For a parallel equation, that'll be our slope. So y equals negative 6/5 x plus b. Now we don't know b. How are we going to find it then in this case? Perfect. That point, it goes through 5, negative 4. Which one goes in for y? Negative 4 goes in for y. Good. And for x? 5. And now we're going to solve for b. So I'm going to do negative 6/5 times 5 is negative 6. And then what do we have to do? Adding 6. We get 2 equals b. So that tells us that equation has to be y equals negative 6/5 x plus 2. Very good. So that's working with the parallels. The perpendiculars, so we had the y equals 3/4 x plus 12. The only piece of information we want out of there is the slope is 3/4. Now since it's a perpendicular, the perpendicular slope is going to be what? Negative 4/3. Good. Opposite reciprocal. So we're going to start out with y equals negative 4/3 x plus b. Good. What's going to go in for b? 3. So y equals negative 4/3 x plus 3. Well, let's look at 34. It's a little more interesting. Y equals negative 6/5 x minus 3. Again, the only piece of information we want out of there is perfect. The slope is negative 6/5. Perfect. The perpendicular slope would be positive 5/6. So we start out with y equals 5/6 x plus b. To find b, what do we use, gentlemen? The 12, negative 5. So what's going to go in for y? Negative 5. And for x? 12. So we have the 5/6 times 12 is 10. Very good. And then to solve for b, we need to subtract 10. So negative 5 minus 10 is a negative 15 equals b. So y equals 5/6 x minus 15. Those look familiar? Good. Now, this worksheet here, we had at the very top, we had these quadratics. And this is where we ran out of time last, well, 2 weeks ago, I guess Friday, was graphing these. And to graph these requires that we're able to factor. For right now, we're going to hold off on these, and we're going to come back to them if we get time in a couple of weeks. we'll go ahead and we'll do these. For right now, though, we've only got, what is this? This is week 4. We've only got about 6 classes left, 6 or 8 classes left in here. So we're going to hold off on that, and we'll come back to that if we get time. So our next step today, we've been graphing these equations, and we did a few at the beginning of the hour. But what if I have like 2y minus 3 equals x plus 1? This one doesn't fit into our y equals form. We can't just graph it. We got to adjust it before we can graph. We have to get the y here by itself. Y has been multiplied by 2 and 3 has been subtracted from it. So to solve it, we've got to reverse that. We've got to undo it. So I'm going to add 3. Leaves me with 2y over here. Remember, when we add or subtract, we only have to do it to one piece on each side of the equation. So adding 3 over here cancels out the negative 3. On the right side, I add 3 to the 1 to give me 4. So on the right side, it's now x plus 4. Very good. Now we divide by 2. When we multiply or divide, we have to do it to every digit in the equation. So on the left side, we divide the 2y divided by 2. Cancels out the y, giving us, or cancels out the 2, just giving us y. On the right side, we have to divide both the x and the 4 by 2. So we think of this as a 1x, and we work that as a fraction. 1x divided by 2, we just take the number that's with the x, the 1, we put it over the 2, so that's 1/2 times x. 4 divided by 2 is plus 2. So that means we're going to start graphing that at positive 2. Perfect. Up 1 over 2 then for our slope. I'd probably do it a couple of times because we are going to need to be pretty precise with these coming up. So we can graph those single equations. Remember, every point on that line was a solution to this equation. If I had the point here, x equals negative 2. Well, if x equals negative 2, we trace that over y equals 1. Negative 2, 1 is a solution to that equation. If I plug it in, y equals 1, x equals negative 2. Well, here 2 times 1 is 2. 2 minus 3 is negative 1. On the right side, negative 2 plus 1 is negative 1. So that makes that equation true. And every point on that line makes that equation true. Every point is a solution to the equation. So what we're going to start dealing with today now is something called systems of equations. And systems of equations are actually very important in construction because there are a lot of things where we have intersecting roof lines and stuff like that where these systems of equations are going to help us figure them out. So we're going to start out with graphing equations. So a system of equations, we might have y equals 2/3 x minus 1 and y equals negative 1/2 x plus 6. And we're going to graph both of those. So let's start out here with the top one. Where do we start? Negative 1, right here. And from there we go
up to over 3.
up to over 3. Right there, right? Let's do it again. Up to over 3. So we've got the line going through those points. For this next one, where do we start? Positive 6 is right there. And from there, where do we go? Down 1 over 2. I'm going to do it again. Down 1 over 2. I'll do it one more time. Down 1 over 2. So I've graphed both equations. Well, in a system of equations, what we are looking for is we're looking for points that make both equations true. In other words, pairs x and y that are solutions to both equations. So now we said that this blue equation, a blue line, is all of the points that are solutions for this top equation. And the green line are all the points that are solution to this bottom equation. What point, or where on this graph would there be a point that's a solution to both of them?
Right where the intersect.
Perfect, where the two lines intersect, where they cross. And that point, because I was really careful graphing this out and I counted my slope several times, that's at 6 and 3 here. So that's at the coordinate 6, 3. Let's test that out to make sure that really is a solution to this system. So in my top equation, I put in 3 for y and 6 for x. Well, 2/3 times 6 is 4. 4 minus 1 is 3. So 3 does equal 3. That makes the top equation true. Let's test it out then in this bottom equation. We put in 3 for y equals negative 1/2 times 6 plus 6. So we have negative 1/2 times 6, which is negative 3. Negative 3 plus 6 is positive 3. So 3 equals 3. So it makes that equation true as well. So that point, 6, 3, is a solution to this system. It makes both equations true. Now, if we look at this, there are only 3 possibilities here. Since we're dealing with linear equations, and that's all we're going to work with, I'm not going to throw in any sort of other fancy equations on us. When we're working with linear equations, so our graph is going to be a straight line for each of them. There's only 2 possibilities, or 3 possibilities. Possibility 1, the lines cross at one point. So there's only one solution. And that solution is the point where they cross. Now there's a second possibility. You can have lines that don't cross. They're parallel. In that case, there is no solution. Now the other case, which happens a lot less often, I have one line. My other line lies right on top of it. In other words, they are the same line. There are 2 different equations for the same line. And in that case, there's an infinite number of solutions. And the solutions would just be listed as the equation for the line. So I could pick either equation and list it. They both describe the same line. That equation is the solution to that system. So let's take y equals 2/3 x minus 5 and 2x minus 3y equals 6. So let's take a peek at this top equation. First of all, is that ready to graph the way it is? Yes. Where do we start? -5. Oops, get back here. So my first point is right here at -5. From there, where do I go? Up to over 3. I'm going to do it again. Up to over 3. So there's the line that describes that equation, or is the solution for that equation. The second one, is that ready to graph?
No.
No, what do I have to do to it?
After I get y to equal, or get y by itself.
Yep, we have to get y equals, or y by itself, exactly. Where would I start to do that? Subtract the 2x, make that go away. So we've got -3y equals 6 minus 2x. Not add 3, the -3 is multiplying y, so to get rid of it, divide by -3. Good. So y equals, what is 6 divided by -3? -2. Now I've got -2x divided by a -3. So a negative divided by a negative is a positive. 2 divided by 3 is just going to be 2 over 3, and then x. So where does that one start?
-2.
-2, and from there I go up 2 over 3. I can go again, up 2 over 3. What's the solution to that system of equations?
Infinite.
Careful. If they're parallel, there are no solutions. There's no place where those two lines will cross. Okay, so looking at this system here. The top equation, is that ready to graph?
No.
No, I have to get y by itself. What am I going to do first with it? Subtract 2x. So y equals 5 minus 2x. It's actually now ready to graph. So where am I going to start? 5, and from there I'm going to go
Down 2 over 1.
perfect. I make that a -2 over 1, so I go down 2 over 1. So there's my line. My second equation, is that ready to graph as it is?
Yes.
Yes, it is. So where am I going to start? In fact, I screwed up here. I'm going to change this just a little bit. I'm going to change that to a 2. Make it work a little easier for us. So now where would I start? Sorry about that.
2.
I would start at 2, and from there I would go
Down 1 over 2.
down 1 over 2. So my line goes right through there. What's the solution here? X equals 2 and y equals 1. So 2, 1. We can always double check to make sure it's a solution. So I'm going to put 2 in for x and 1 in for y. So in the top equation, 2 times 2 plus 1. Well, 2 times 2 is 4. And 4 plus 1 is 5. So 5 equals 5. So the top solution works, top equation works. Let's look at the bottom equation. So I put in 1 for y, 2 for x. 1/2 times 2 is 1. Plus 2 is 3. Something went wrong there. Oh, I graphed it wrong. That should have been a negative 1/2. So I screwed that one up. That one's totally my fault. But yeah, that's supposed to be a negative 1/2 in the equation. That's what I graphed. I don't know why I didn't write it that way. So sorry about that. Y equals negative 1/2 x plus 2. So negative 1/2 times 2 is negative 1. Plus 2 is 1. So 1 equals 1. So then it would make that equation true. Okay, it's about break time there, it looks like. So let's go ahead and let's take about a 3-minute break. And we'll come back about 2:47, 2:48. Okay, so let's do some more examples of this to see some of the other things that can come about. We might have something like 3x plus 3x plus 2y equals 4. And y equals 2x plus 2x plus 9. So if we go to graph this, the top equation, is that ready to graph? No, so we're going to have to work with that a little bit. So 3x plus 2y equals 4. Where do we have to start working with that one? Perfect. Perfect. We subtract the 3x. So we're left with 2y here. 4 minus 3x is 4 minus 3x. Then what? Divide by 2. So we have y by itself here. 4 divided by 2? 2. Negative 3x divided by 2? Negative 3 over 2x. So where do we start graphing this one? Positive 2. Good. From there, where do we go? Down 3 over 2. So there's our line going through there. Now our second equation here, is that ready to graph?
Yes.
Yes, it is. Where do we start?
9.
We start at 9. And from there we go
Down 2 over 1.
well, it's a positive 2, so we'd actually go up 2 over 1. So it's right there. We see that that's heading in the wrong direction. They're heading away from each other. So I'm going to back it up. So I'm going to go back 1 and down 2. Back 1 and down 2. We get to right there, and we see if I went with my green line to be a little more precise, back 2 and up 3. We find that they actually cross at that point there, which is right there at -2, +5. Have a seat, guys. Okay, guys, enough shooting practice. Sorry, but it sounds like somebody in the hallway already isn't too happy. So. Yeah. So now let's do another example here. Let's do y equals 2/3 x minus 2 and 2x minus 3y equals 6. So we go to graph these. We'll start out with the y equals 2/3 x minus 2. Where do we start? -2, good. And from there, what do we do? Up 2 over 3, good. Now, our second equation here, what do we have to do to make that graphable?
Subtract 2x.
We subtract the 2x, very good. So we've got -3y equals 6 minus 2x. Then what?
Divide by -3.
We divide by -3, good. So we've got y there. What's 6 divided by -3? 6 divided by -3 is -2, good. -2x divided by -3? Perfect, positive 2/3 x. Negative divided by a negative is a positive. Then we take the coefficient of x just over what we're dividing by. So 2 over 3 x. So where do we start with that one? -2, and from there, where do we go? Up 2 over 3, that gives us that line. So what's our solution here? There's an infinite many solutions here, infinite number of solutions. And to state the solutions for this, we would just state one of the original equations. So either one of these two equations could be listed. They're solutions because they overlap the whole line. The complete line is an equation. So I'm just going to list y equals 2/3 x minus 2 as my solution. Because every point on that line is a solution to both equations. Well, how about this one? So both of these equations have to be solved before we can do anything with them. Let's start out with the top equation here. Oops, way back here. I'll slide it over so I got a little room here. So yes, we got 3x plus 2y equals 8. And as you said, we would subtract 3x. So we've got 2y equals what?
8 minus 3x.
8 minus 3x. What would be next?
Divide by 2.
Divide by 2 to get y by itself. So y equals what? 8 divided by 2 is 4. You could do negative 3x divided by 2. You could do negative 1.5x, or negative 3 over 2x is easier because it has it in that slope form for us. So now we're going to start out at what?
4.
Positive 4. 1, 2, 3, 4. And from there we're going to go down 3 over 2. I could go down 3 again over 2. There's my line. What's next? On the second equation, where do we start? We're going to have to subtract x. We've got to get y by itself. So we've got negative 3y equals 6 minus x. What's next? Divide by negative 3. So y equals it is 1 over 3x, but it's a negative divided by negative, so it'll be positive. So where do we start?
Negative 2.
Negative 2, and from there we go up 1 over 3. Notice that is not on the line. These two lines do not cross at a grid point. So it's going to be decimals, the answer is going to be. Well, if we're graphing to solve equations, if we get a decimal answer, it's really tough to find that exact answer by graphing them. Unless we're using a computer program to graph them where the computer can actually trace them and tell us where they cross, it's really not a practical way of solving equations that don't have exact answers, don't have whole number or integer answers. So if the equations, the solution to the system is going to be decimals or fractions, we need a way of calculating it without trying to graph it. So we're going to look at algebraic methods of solving. So the first way we're going to look at is, let's look at these two equations here. Y equals negative 1/2 x plus 4. And y equals 3 over 2x minus 4. See where that takes us. These we could graph out if we wanted to. Where would we start with this top equation when we graph them? Positive 4. And from there we would go down 1 over 2. And we'd go again down 1 over 2. We draw our line in. The second one would start at negative. And there we go up 3 over 2. Good. Let's do it again. Up 3 over 2. So those lines cross right there. That coordinate, if I drew it out carefully, is it the coordinate 4, 2. I could double check it in both equations and it would work. We've checked enough that I don't have to do it again for you. But now, what we know about this point is that the y value of this equation has to equal the y value of that equation. So in other words, those two y's are equal to each other. We happen to know that both of them equal 2 in this case because we've solved it already. But even if we haven't solved it, we know that this y has to equal this y. So what I can do is I can substitute this y into that equation. But this y is equal to 3/2 x minus 4. So what I'm going to do is I'm going to rewrite this top equation. But instead of writing y, I'm going to put in 3/2x minus 4. So what I've done there is I've replaced y here. I've substituted this in for it because I know y equals that. So then the other side is still the negative 1/2 x plus 4. Oops, that should be 4 there. 3/2 x minus 4. So now I just have to solve this to find out what x is. Now I have an x on each side, and we can't deal with that. We have to get rid of one of them. Which one are we going to get rid of here?
The smaller one.
The smaller one. So one of them is negative. That has to be smaller than a positive. Negative 1/2 x, we'll get rid of it by adding 1/2 x. So that'll be gone. Leaves us with 4 over here. When we add or subtract, we only have to add or subtract to one piece on each side. So we add 1/2 x over here. 3/2 plus 1/2 would be 4/2 or 2x. So now what do we do to solve this? We add 4. So 2x equals 4 plus 4 is 8. And then we divide by 2. You got it. X equals 4. Which is what we had over here. X is 4. So we have x equals 4 at this point. We still need to find y. So we have to go back to one of the original equations. Either one of them, it doesn't matter. I'm just going to take the top one because it's on top. And I need to replace x with 4. So instead of negative 1/2 times x, it's negative 1/2 times 4 plus 4. To figure out what y is going to be. So negative 1/2 times 4 is negative 2. Negative 2 plus 4 is 2. So y equals 2. Good. Which is what we had. We had x is 4, y is 2. Now we should write that. We can write it x equals 4, y equals 2. That's fine, but it's more proper to write it as an ordered pair, as 4, 2. Now when we do these algebraically, what we did here is called substitution, by the way. Because what we did was we took one of the variables, in this case it was the y in this second equation. Boy, is that a mess. Let me get some of this other stuff. In this case, what we took was the y in this second equation, and we put it in for the y in the other equation. We took an expression for this y and put it in there. Not all of our systems of equations are going to be this neat, though. They're not going to be solved for one variable or the other. Yeah, so let's take something like, 2 negative 3 is going to go in the solution here. Let's do x equals 2y plus 8. 5x plus y equals 7. So looking at this system of equations here, first thing we look for is if there's one or more equations that is solved for, either x equals or y equals. Do we have one of those in this system?
Yes.
Yeah, this top one is x equals. So we know that x equals 2y plus 8. So what that's telling us is where we see x, we can replace it with 2y plus 8. So I'm going to rewrite this second equation. Instead of 5 times x, so I'm going to get some stray marks here. Instead of 5 times x, I'm going to put in 5 times, instead of x, 2y plus 8. Because I know that x equals 2y plus 8. Plus y equals 7. And now I only have y's in this equation, so I can solve it. What am I going to do next to solve this equation? Well, I have the parentheses, which are drawing my attention. What do I have to do with those parentheses? Multiply by 5. Good. 5 times 2y is? 5 times 2y is 10y. 5 times 8 is 40. Good. Then we still have the plus y there. Hey guys, let's stop throwing stuff. Okay, so now we've got the y appears twice, but both on the same side. So what do we do with them? We combine them. 10y and y make 11y. Plus 40 equals 7. And then what? Careful. You're a step ahead of yourself. We subtract the 40. Good. So 11y equals, what's 7 minus 40?
Negative 33.
Negative 33. And finally, we divide by 11. Y equals a negative 3. So we know y equals a negative 3. Now we're going to find x by going back to one of the original equations. Now here I'm going to go back to this top equation because it's already solved for x equals. So 2 times y, I'm going to put in negative 3 where the y is. So 2 times negative 3 plus 8. What do I do next there?
2 times negative 3 would be negative 6.
2 times negative 3 is negative 6. Negative 6 plus 8 is positive 2. So x equals 2. So x is 2, y is negative 3. So 2, negative 3 is the solution to that system of equations. How are we doing? Tired? All right. I hear you. 3 o'clock in the afternoon is not the best time to be learning math, is it? One more example, and I'll give you guys some homework, okay? Can you please get a quiz today? Okay, so let's take a look at (3x plus 2y equals 7). Negative 2x plus y equals 7. So looking at these, again we ask, is one of them solved for a variable? So solve for either x equals or y equals. In this case, is either one of them set up like that? No, it's not. So that doesn't work. That's not going to happen. So the second thing we look for, is there one that's easy to solve for a variable? So easy to solve for x or y. And what I mean by that is, are there any that have, a 1 multiplying x or y? By a 1, 1x is just going to be written as x, 1y is just going to be written as y. And in this case, I do have that. I have just y here. That would be 1y. So that means it's going to be easy to solve for y there. Now, if I don't have that, the next one is they're going to be easy to divide by. And we'll see those examples more on Friday. So we can easily divide by 1. That's why we're going after the y, the 1y here. Because dividing by 1 is not going to give us any fractions or decimals. By easy to divide by, we would look at numbers that are going to give us easy fractions or easy decimals. Like dividing by 2 is going to give us a decimal 0.5. Dividing by 4 would give us 0.25. 5 would give us 0.2. We would not want to divide by 3 because 3, in many cases, is going to give us a repeating decimal. The same with 6 and 7. So there's only certain numbers we want to divide by if we can avoid the other ones. So here, since this bottom equation has a y all by itself, we're going to solve this equation for y, and we're going to use that then for a substitution. So how am I going to solve that for y? What do I have to do? Add 2x. It's a negative 2x, so adding 2x makes it disappear. I have to add 2x to the other side. So y is by itself here. 7 plus 2x is 7 plus 2x. So now I have that y equals 7 plus 2x. So that means I can come up to this top equation, and I can replace y with 7 plus 2x. So 3x plus 2, instead of y, I'm going to put in 7 plus 2x equals 7. So now I just have to solve this equation. What's my first step solving this equation? Perfect. I have the parentheses here. 2 times 7 gives me 14. 2 times 2x is positive 4x. Now I still have the 3x up front here, so I got to put that in there. This is a positive 14, so I'm going to put a plus in front of it. Now what do I have to do? Perfect. I got 3x and 4x, both on the same side of the equal sign. So I combine them to get 7x. Then what?
Subtract 14.
I can subtract 14. So I got 7x here. 14 minus 14 cancels out. 7 minus 14 is negative 7. And then finally we will divide by 7. So x equals negative 1. So I've got x equals negative 1. What do I do with that? I go back to either one of my original equations up here. I can go back to one of these, or what I'm going to do is I'm going to slip down to this one here. I solved this equation for y to get that. And since that's already solved for y, it'll be pretty simple to put this number in for x and find y. So y equals 7 plus 2 times x. Well, instead of x, I'm going to put in negative 1. So y equals 7 plus, what's 2 times negative 1? Negative 2. And what is 7 plus negative 2? Positive 5. So y equals 5. So x equals negative 1. Y equals positive 5. So my solution is negative 1 for x, 5 for y. So negative 1, 5. is the solution to that system. Okay, I think you guys have probably had enough for the day. So in your big book, page 409 through 410, this is exercise 17-1. Problems 1 through 17. I have you work on those graphing to solve for a system of equations. Are you guys done hugging back there? Okay. Solve with graphing to solve the system of equations. On Friday, we'll talk more about substitution, and then there's another algebraic method we'll talk about. And then on Friday, there will be a quiz on graphing systems.